Simplifying exponential expressions. In this video, we're going to just do some examples, simplify some exponential expressions that have negative exponents. We're going to do it slowly, step by step. When I'm simplifying expressions with negative exponents, I sometimes think of that negative sign as a traveling ticket that takes the expression over the fraction bar. For example, if I have a to the negative 8th and I rewrite it as a to the negative 8th over 1, and then I say, oh look, 8 has a ticket. It's going to make the whole expression a to the 8th travel and turn in the ticket when you're done. Now there's a 1 on top, so a to the negative 8 equals 1 over a to the 8. Similarly here, since I have a to the negative 8 in the denominator, but the negative is a ticket to travel, the a to the 8 expression is going to come up to the numerator, and 1 is in the denominator. So that's just equal to a to the 8th. Let's simplify 3y to the 3rd over 2y to the 7th, all to the negative 3rd power. I'm going to start by simplifying inside the parentheses. I'm going to separate out the numbers from the variables so that I can simplify the variable expression. y third over y 7th is y to the 3 minus 7 power. 3 minus 7 is negative 4, so we have y to the negative 4 power. Now let's distribute the negative 3 outside into the multiplication in the parentheses. 3 halves is to the negative 3 power, and y to the negative 4 is to the negative 3 power. Just like a multiplication, the negative 3 distributes over the division as well, and y to the negative 4th to the negative 3 power is y to the negative 4 times negative 3 power. Well, let's use the negatives to travel. 2 to the negative 3 travels to the top and becomes 2 to the 3rd. And 3 to the negative 3 travels to the bottom and becomes 3 to the 3rd. Y to the negative 4 times negative 3 power is y to the 12th. So when we finish up here, what we have is 2 to the 3rd, that's 8. 3 to the 3rd is 27, and y to the 12th. We've simplified that expression. We're going to simplify this quite complicated expression, 2uv squared over w to the negative 1, all to the negative 2 power, times v to the negative 3 w7. Well, I'm going to start by simplifying inside the parentheses, and even though I don't have any exponential terms with like bases, I have a negative 1 in the denominator. So I'm going to rewrite that. The 2uv squared in the numerator stays the same. W to the negative 1 travels up and is just w to the 1, or w, in the parentheses. That's all to the negative 2 power. And then we just copy the multiplication so we have it for later. Now I'm going to take the negative 2 exponent and give it to all the factors inside the parentheses. So 2 is to the negative 2 power, and u is to the negative 2 power, and v squared is to the negative 2 power, and w is to the negative 2 power. And that's all going to be multiplied by v to the negative 3, w to the 7th. There's only one thing to simplify in this expression. v squared to the negative 2 power needs to be written as 2 times negative 2 v to the negative 4 power. And I'm just going to copy the rest so I have it, w to the negative 2, v to the negative 3, and w to the 7th. Now I have some exponential terms with like bases, so I'm going to regroup so that they're together. V negative 4 times v negative 3, and w negative 2 times w to the 7th. Well, now I can simplify those multiplications. V is v to the negative 4 plus negative 3, which is negative 7. Is w negative 2 plus 7, w to the 5th. So 2 to the negative 2, u to the negative 2, v to the negative 7, w to the 5th. Now I want to rewrite it without any negative exponents. 2 to the negative 2 is going to give me a 2 squared in the denominator. U to the negative 2 gives me a u squared in the denominator. And v to the negative 7 gives me a v7 in the denominator. W here is to a positive power, so w to the 5th stays in the numerator. Well, so I've simplified. The expression simplifies to w to the 5th over 2 squared, which is 4, u squared v7.